This is a fossil. This is an amazing fossil because it shows us a dinosaur that swam in the sea. It's from a group of dinosaurs called the Spinosaurus. And they are really fascinating because they kind of defy evolution. Okay, so hear me out here. The fossil record is great at showing us how life has changed over time. But to do this, we need fossils of transitional forms, fossils of organisms that show us the intermediate stages between two very different kinds of animals. You can think of them like the stepping stones on an evolutionary path. But there's a problem with using fossils to figure out how life has changed over time, and it's a big one. The fossil record is patchy. Fossils are rare. We just don't have enough of them to trace all of these evolutionary paths. Sometimes the fossil record will surprise us and fill in these gaps. But other times the gaps remain, and some evolutionary transitions just never get a good representation in the fossil record. One example of this is the origin of birds, which is still a bit of a mystery due to the lack of good transitional fossils. Now, if you want to learn about the origins of birds, you could turn to living birds and their relatives today and use a field of study called paleontology to piece together how they might have evolved. Paleontology uses living organisms to make inferences about their extinct relatives. It's basically reverse engineering evolution. And sometimes this can help us understand those pesky gaps in the fossil record. The thing is, though, not everyone thinks that this is a good approach. Some people think we shouldn't speculate about what fossils must look like if they existed just because we're lacking them in the fossil record. They want tangible evidence, actual fossils. So this is where our Spinosaurus fossil comes in, because it could potentially rewrite what we thought was possible for land reptiles. Spinosaurus is the only known dinosaur that was adapted for swimming. It was the size of a bus and had a huge, broad skull and a long, narrow body. Its jaws were lined with pointy teeth that would have been great for catching fish. Its eyes were on the sides of its head, which gave it binocular vision. Basically, it was perfectly built for an aquatic lifestyle. It lived in what is now North Africa around 95 million years ago, and fossils have been found in Morocco, Algeria, and Egypt. Most of these fossils consist of a few bone fragments and a couple of teeth. And this is where things start to get weird. In 2000, a researcher named Eric Storm set out to understand the evolution of Spinosaurus. He collected more specimens and studied the anatomy of the group, starting to paint a picture of how it spent its time both on land and in the water. This is when he made a shocking discovery. As far as he could tell, Spinosaurus had no ankles. Like many reptiles today, it had a kind of wrist structure called a carp, which allows for a wide range of motion in the hand while on land. But what's strange is that the wrist has no function in the water. In fact, many aquatic animals have shortened or even lost their wrists entirely to be more streamlined. Fish obviously have wrists that are basically non-existent. Whales have tiny vestiges of what used to be hands. And turtles, well, they've completely lost them. Their wrists are gone. So why does Spinosaurus have a wrist if it spent most of its time in the water? Well, the answer may lie in the fossil record. Between 2008 and 2013, a research team unearthed a new collection of Spinosaurus fossils in Egypt. These included bones from at least 12 individuals, including the first nearly complete skeleton. This was exciting because it meant that they could compare multiple specimens and better understand how the group evolved. One of the fossils was a partial foot from what they think was a juvenile Spinosaurus. And when they compared it to the wrist of a more primitive relative, they saw that the ankle bones hadn't disappeared yet, but they were pretty much useless. They were small and didn't connect to each other very well. So they couldn't take the weight of the animal. So it seems like Spinosaurus kept evolving after it split off from its relatives and moved into the water. So then why didn't its ankles just disappear? Well, evolution doesn't always work in straightforward ways. There are lots of factors that can influence the rate of evolution, such as generation time, population size, mutation rates, and natural selection, of course. But all of these factors vary across species. Different species will evolve in different ways. For example, if you look at the wrists of whales and turtles, you can see that they've reduced in different ways. Turtles seem to have gotten rid of their wrists by slowing down the growth of their wrist bones. The bones just stopped developing, basically. Whales, on the other hand, seem to have kept their wrists around longer. They kind of tucked them under their body so they weren't as visible. Then, over millions of years, they started to fuse the bones together, making them shorter and less mobile. So maybe Spinosaurus did something similar. Maybe it kept its ancestral wrist bones around and covered them up. Or maybe it actively selected for more mobile wrists so it could walk around on land. After all, it needed to be able to move around on land to get to the water. It also needed to be able to climb up on land to lay its eggs, like other reptiles. But there's a problem with this idea. If you look at the fossilized footprints of Spinosaurus, they don't seem to have wrists. They look like the footprints of modern crocodilians, so they may have evolved again to lose their wrists, possibly because it was advantageous for moving around on land. So then why didn't it just stick with the wrist structure it got from its ancestors? Well, it may have actually lost its ancestral wrist twice. Now, this is just a hypothesis, but it may be supported by the fact that Spinosaurus kept growing larger and larger over time. And as you grow, the parts of your body scale with it. As you get bigger, you often need stronger bones to support your weight. So as Spinosaurus grew, its wrists may have become more fragile, and it may have needed to keep strengthening them to compensate. That would have made it harder to adapt to life in the water. So perhaps it took the ancestral route of reducing its wrists a second time. Now, obviously, this is all speculation. These are interpretations of the available evidence. But it's still really interesting to think about how an animal can evolve so many different ways to adapt to its environment. And honestly, it makes sense that we haven't found any fossils showing these evolutionary transitions. As I said before, evolution isn't a straight line. It doesn't go from A to B. It's more like a bush with lots of different lineages evolving in different directions. If we're missing the fossils of several key transitional forms, we wouldn't expect to find a dinosaur that lost its ankles twice just because it hasn't happened within our frame of reference. So even though we don't have fossils that show us the exact steps Spinosaurus took to lose its ankles, we can still use the fossil evidence we do have to piece together its evolutionary history. And this can help fill in the gaps in the fossil record and maybe give us clues about other extinct groups that seemed impossible. Who knows? Maybe somewhere out there is a Jurassic Park-style animal that defies our current understanding of evolution, and it's waiting to be discovered. If you liked learning about this animal, please leave a like and watch another episode. Thanks for watching. See ya.